With the main printer now constructed and complete, it's time to start calibrating so it's ready for use, although we need somewhere to place our spool of filament first, so on we go with the spool holder assembly. Although there are two versions of the spool holder available, if you have a new kit, chances are you have the newer injection moulded version, which we'll concentrate on here. So with all parts to hand, we'll crack straight on. We'll begin with one side of the base, and with the inside facing upwards, insert two wheels. And then cover the assembly with the top half. Push both halves together until they meet and fully engage. With that done, repeat the same process again for the opposite side. Foam pads next. What looks like one piece is actually several smaller pieces when you bend the pad. Remove a piece at a time and place two on the inner edges under the spool holders we've just constructed, and 4 on the ends, 2 on either side. Repeat the same on the second unit, so 2 in the middle, and 2 on either end. Finally, slide each part into the central guide. And with that, the spool holder assembly is complete. To use the holder, simply place a spool of filament on the wheels, aligning the ends to match the spool. The spool should then turn freely. Okay, so now we have our constructed printer, as well as our separate spool holder with filament in place, so we're ready to power up and calibrate the machine. We'll begin by setting the correct height for the superpinder sensor on the print head. Using your fingers, turn the Z-axis lead screw carefully and move the entire X-axis down. Stop when the hot end just touches the heat bed. Avoid going any further as you could end up bending the heat bed. Now slightly release the screw on the sensor holder so you are able to adjust the position of the superpinder sensor. Using the center of a zip tie placed just under the sensor, gently press the superpinder sensor down against the zip tie. Fortunately, mine is pretty much spot on already. After which we can tighten the screw on the holder again. Do not use excessive force as you could end up breaking the printed part, just enough to secure the sensor in place. Finally, rotate the Z-axis lead screw manually in the opposite direction to move the axis a little up and away from the heat bed. And this will provide space to install our steel printing sheet. Note the sheet will stick to the magnets built onto the heat bed with some force, so take care to gently place the sheet into position. Now we can remove the plastic sheet from the display and insert the power cable. At this point, it's a good idea to head over to the Prusa website and download the latest stable firmware release. Transfer the downloaded file to the root of a USB device. The drive included with your printer is perfectly fine. And then insert the drive into the side USB port on the printer before powering up. The printer will detect and apply the firmware update should it be needed, after which the setup wizard will begin, which takes the system through a variety of self-tests in order to check and validate all the important components of the printer. The tests are designed to reveal the most common issues, such as incorrect wiring. They consist of the extruder and print fan test, then each of the 3 axes starting with the X, moving to the Y, and finally the Z. The progress and result of each step are displayed on the LCD screen. In case any issues are found, the self-test is interrupted and the cause of the error is shown to guide you in troubleshooting. We're all good in my example, so next comes the filament sensor test, in which you're asked to load some filament. A sample will have been included with your printer and can be used here, so proceed as directed and the filament will be pulled through and out of the nozzle. With all that done, we need to follow the first layer calibration wizard. This is a fine art that you'll become accustomed to over time, although thankfully it's not something you'll need to do very often if you use the same type of filament regularly. During this calibration, the printer will probe the bed and then begin to print a series of zigzag lines. Use the control knob to raise or lower the nozzle very slightly in order to ensure the plastic is squished onto the sheet as shown in the manual you have received with your printer. The process could take a while and some test prints needed in between, but once dialed in, you're good to go. And that's it! Prusa Mini Plus 3D printer build complete and ready to print your very own 3D plastic models, functional parts, or anything else you can think of. Although there are a huge variety of freely available models to download and print from printables.com, there are a few models on the included USB drive to get you started, and it's good to choose one for your first test print even though all calibration tests have passed. There's no test like printing an actual model through to completion after all. Nevertheless, not only does the Mini Plus make for a great beginner level 3D printer since it's super reliable, quiet and easy to use, it's also perfect for running in larger numbers, in a print farm for example. Anywhere where smaller sized objects are the primary goal, it really is a great all-rounder. If you have any issues from here, check the troubleshooting section of the handbook, or alternatively head over to the official Prusa forum for help and support should you need it, or even just to share your experiences with the build and with your own 3D models. For now though, it's happy printing!